Welcome to the deep dive. Today, we're plunging into something really fundamental data.
Absolutely. It's everywhere.
Yeah, so we're going to explore how it gets collected, how it gets into systems, and then, the whole journey it takes, its life cycle.
From start to finish.
Exactly.
Yeah.
And this deep dive is built just for you, using the material you provided. I mean, just think about the amount of data flying around now. It's kind of staggering, right?
Oh, definitely. Transaction systems, IoT devices, AI generating stuff, people just typing things in.
That's a flood. And, well, businesses need to figure out how to handle it all. It's not just tech, it's strategy.
That's exactly right. And that's sort of our mission today, isn't it? To cut through that complexity for you.
Yeah.
We want to unpack the actual process, the steps data goes through. That's the life cycle bit. And then look at, well, how does it even get collected in the first place?
Right. Turning all that noise into something clear, some actual insight.
Hopefully giving you a solid framework.
Yeah. So by the end, you'll have this kind of roadmap, this mental model for how data is managed or, how it should be managed.
Responsibly and effectively, yeah.
And we're here to guide you through it, pointing out the really key stuff from your material.
Okay, let's kick things off. So the sources make it really clear from the get-go, data is just essential now.
Not just nice to have.
No, not at all. It's driving decisions. It makes audits possible. It's the foundation for any kind of analysis. It's just woven into everything.
From simple records to, complex AI stuff.
Exactly that. It's pervasive, which means you can't just be casual about how you handle it.
Right. You need a system.
Precisely. Companies need a systematic approach. They need to know what data they have, where it came from, how good it is, how it's being used. And that systematic approach, that's the data life cycle.
Okay, so the life cycle is the management framework.
Think of it like,
Okay.
like the official journey for business data. It lays out the sequence of steps, from idea to creation through its useful period, then maybe storage, and finally, getting rid of it securely.
It provides structure.
Yeah, governance and structure in the face of all that data creation.
And your sources mention 8 specific steps in this journey. Can you walk us through the overview?
Sure. It starts logically with step 1, definition. What do we actually need?
Okay.
Then step 2 is capture or creation, actually getting the data.
Right.
After that, it's not ready yet. It goes into these pre-analysis stages. Step 3 is preparation.
Totally got it.
A lot of tidying up, yeah. And then step 4, which is sometimes needed, called synthesis.
Okay.
Then comes the main event, really. Step 5, analytics and usage, putting it to work.
Makes sense.
If you need to share it outside the company, that's a distinct step. Step 6, publication. Then, as data gets older and less used, it goes into step 7.
Archival.
Long-term storage.
Right. And the very final step, when it's truly done, is step 8, purging. Getting rid of it completely.
Definition, capture, preparation, synthesis, usage, publication, archival, purging. Wow. Okay. That's quite the journey. Why does understanding all that matter for you listening? Well, it matters because it's not just some abstract IT thing. Understanding this cycle helps you understand where the data you use comes from and how trustworthy it might be.
The quality and lineage.
Exactly. And that directly impacts the quality of your decisions. If you know the data went through rigorous preparation, you can trust it more.
Right.
It also helps reduce risk because data is handled predictably, securely, and ultimately, it makes things more efficient.
Can you give an example?
Sure, think about a report you use, or maybe the feed in an app you check, or your online shopping history. That data didn't just appear, it likely went through some version of this cycle. Thinking about that makes it less invisible.
That's a good point. It puts structure around it. Okay, let's start at the very beginning then. Step 1, definition. What exactly happens here?
So this is crucial. It's the strategic start. Before you collect anything, you define what data you actually need.
Not just grabbing everything.
Definitely not. It has to be tied to specific business goals or questions. You identify the exact information needed. If you're trying to improve marketing, you need marketing data, not necessarily factory floor sensor data for that specific goal.
So it's about relevance. Defining the scope up front.
Absolutely. What specific data points, what metrics, what information answers this business question?
And the sources also say you figure out where to get it at this stage.
Yes, that's part of definition. Once you know what you need, say, customer purchase history, you also identify where it lives. Is it in the sales database? The CRM system? A third-party source?
Why nail that down so early?
Because the source affects everything that follows how you capture it, what preparation it might need. Is it clean already? Is it structured? Is it internal or external? Knowing the source helps you plan.
Okay, so definition is about Focused planning. What data, from where, for what purpose? It sounds foundational. What if a company messes this part up? Skips it, or does it poorly?
Oh, that's where things go wrong fast. If you don't define properly, you risk collecting totally the wrong data.
Useless data.
Or maybe worse, you collect way too much data, most of it irrelevant. Imagine trying to understand website conversion rates, but forgetting to define and source data about the traffic sources. You see the conversions, but not where they came from.
Can't answer the why.
Exactly. Or you collect terabytes of server logs, but miss the key customer feedback data. It wastes time, money, storage, analysts drowning in noise.
Okay.
And crucially, you just can't answer your business questions properly. Bad definition leads to bad analysis, leads to bad decisions. It really undermines everything else.
So time spent here saves a lot of pain later. Okay, makes sense. Once you've defined what you need and where it is, then you actually go get it. Step 2, capture or creation.
Exactly. Now you obtain the data. The sources talk about two main paths here. Either the company creates the data itself internally,
Like generating it through its own activities.
right, or it captures data from an external source.
Let's look at internal creation first. Data born inside the company.
Yep, generated by the company's own operations or systems. And the sources break down how this happens based on, well, how much a person is involved.
Okay, like manual creation, someone typing in an order.
That's the most direct way. An employee physically keys information into a system. Think call center agent typing in customer details. Simple concept, but prone to typos or human error if you're not careful.
Sure. Then there's automatic creation. System logs, EDI.
Right. This is data generated automatically without someone actively typing it at that moment. System logs just happen, software recording events, errors, performance.
Like a server log.
Yeah, and EDI, electronic data interchange, that's systems talking directly to other systems, exchanging things like purchase orders or invoices automatically using standard formats. Very efficient for routine stuff.
And the third one was semi-automatic. The example was OCR on a PDF sales order. Then an employee reviews it.
That's a great example. It mixes automation with a human check. So you get a PDF order. Instead of typing it all out again, software uses OCR, optical character recognition, to try and read it automatically.
Pulls out the customer name, items, quantities.
Exactly. But OCR isn't perfect, right? Especially with different looking documents. So the system extracts what it can, then shows it to an employee who quickly verifies it, corrects any mistakes, and then approves it into the main system.
Automation for speed, human for accuracy.
It's a good balance. So internal creation spans that whole range. Now, what about the other path, capturing data from external sources?
Data from outside the company.
Right. Market data feeds, maybe social media analytics, government stats, data from partners, lots of possibilities. But this comes with extra baggage compared to internal data.
What kind of baggage? The sources mentioned integrity, safety, copyrights.
All of the above. Integrity and safety are key. You need to trust the source, make sure the data is accurate and isn't going to, cause problems in your systems.
Like malware or something.
Potentially, or just corrupted data. But the copyrights and other requirements are a big one, too. External data isn't usually free.
Licensing.
Often, yeah. It's probably someone else's intellectual property. So you'll likely need contracts. These contracts spell out exactly how you can use the data, maybe privacy rules you have to follow, especially with personal info, and yes, often there are fees involved. You're buying access to an asset.
So external data brings in legal and financial hurdles right at the start.
Definitely adds complexity. You need that due diligence. Is it legal? Is it good quality? Before you even pull it in.
Okay, so step 1, define. Step 2, capture or create internally or externally. Now we have the raw data. Is it ready to use?
Almost certainly not. And this is where we hit arguably the most labor-intensive parts. Step 3, preparation, and then step 4, synthesis. The sources frame these as the essential steps before you can analyze or use the data properly.
The bridge to usability.
Exactly. Step 3, preparation, is all about getting that raw data into shapes. Is it complete? Is it clean? Is it current? Is it secure, often encrypted? Is it actually user-friendly for whatever comes next?
And there are several distinct activities within preparation, right? Where do we start?
Let's start with ensuring completeness and integrity. This is vital because just moving data around can break it. Records can get lost, data can get changed accidentally or, maliciously. Duplicates can creep in.
So you have to check you got what you thought you were getting.
Absolutely. You have to verify that the data arrived intact and complete. The sources give 4 validation checks for this right after capture.
Okay, what's the first one?
Simple but effective. Record counts. Compare the number of records you expected from the source to the number you actually received. If they don't match Houston, we have a problem. Rows are missing.
Basic check. Makes sense. Second,
Compare descriptive statistics for number fields. If the source can give you, say, the sum or average of a sales column, you calculate the same on the data you received and compare. If the numbers are off, it could mean missing values, wrong data types, messing up calculations, or other corruption.
like if the total sales figure dropped unexpectedly during transfer.
Big red flag, yeah. Third validation, field formats. Are dates actually dates? Are numbers stored as numbers, not text? Are text fields really text? Inconsistencies here will break analysis tools later.
Got it. Ensuring data types match. And the fourth.
Comparing character limits. This checks for truncation. If your source system allowed 500 characters for a product description, but your target system only allows 250.
You lose half the description for long entries.
Exactly. Comparing those limits helps catch potential data loss.
These checks feel quite technical, but skipping them sounds like it could cause chaos. What really goes wrong if data is incomplete or corrupted?
The downstream effects are huge. Everything you do after this point cleaning, analysis, reporting decisions is built on that flawed data. Analysis will be wrong, reports misleading, decisions unreliable.
Like using bad inventory numbers.
Right. Promising stock you don't have, or using messed up financial data for reporting. The consequences can be anything from unhappy customers and wasted effort to massive financial hits, regulatory fines, even legal trouble if compliance depends on accurate data. It just destroys trust.
Okay, that clearly underlines why validation is non-negotiable. What else happens in preparation?
Data integration comes next, especially if you're bringing in external data or combining data from different internal systems.
Right.
Your setup, your data architecture needs to handle merging these different streams.
Building the pipes to connect them.
Pretty much. You need reliable data pipelines to get data from source A and source B into your main analysis environment, like a data warehouse. And if these sources update constantly, you need to make sure those updates flow in correctly and on time. Stale data can be just as bad as wrong data.
What makes integrating data from different places tricky?
Oh, lots of things. Different formats, you know. Fields might be named differently even if they mean the same thing. Data might be at different levels of detail, daily versus monthly summaries. Update schedules might vary. You need to map fields, transform data so it fits together, handle errors in the feeds, make sure the timing works. It's like assembling IKEA furniture where every part came from a different store.
Okay, validation and integration. What's the next big piece of preparation?
Data cleaning. So you validated the transfer was okay. You've integrated sources if needed. Now you look inside the data itself and fix the quality issues, the errors, the inconsistencies. This is the real tidying up.
Getting rid of the mess within the data rows.
Exactly. The sources list practical cleaning steps. First, stripping out things like report headers or subtotals that might have come along with the raw data. Good for humans reading a report, bad for machines trying to process data.
Just the facts, ma'am.
Right. Second, standardizing things, getting rid of weird leading zeros, non-printing characters that snuck in somehow, making it consistent.
And negative numbers.
That's the third one. Make sure they're all formatted the same way. Minus sign, parentheses, trailing minus. Pick one standard and convert everything to match, otherwise calculations get messed up.
Okay. Then the fourth is about fixing inconsistencies, like the CA, CALF example for California.
A classic data quality nightmare. If you have the same state or product or city represented in multiple different ways in your data,
Your analysis will treat them as different things.
exactly, you can't group by state accurately or count customers properly. Cleaning involves finding all those variations, CA, Cal, Califol, California, and standardizing them to one consistent value, CA or California. This applies to any text field where consistency matters for grouping or filtering.
That example makes it very clear. Without that step, your counts and groupings are just wrong.
Totally wrong. And the fifth cleaning step mentioned is tackling inconsistent data types within a column. Maybe a column is supposed to be dates, but it has some text like NA or just numbers mixed in. You need to find those, fix them if possible, or flag them as invalid so the whole column can be treated reliably as, say, a date field.
So cleaning is about making the data itself consistent and error-free after you've confirmed it transferred. Okay. Why is this so vital for analysis?
Because clean data is the absolute bedrock of trustworthy analysis. It's the whole garbage in, garbage out principle. If you analyze dirty data, your results are garbage.
Right.
Inconsistent entries mess up counts and sums, errors distort averages, missing or badly formatted values break models. Cleaning ensures your insights actually reflect reality, not just data glitches. It builds confidence.
Preparation sounds like where the real heavy lifting happens.
Right.
What about the last part mentioned? Data encryption.
Right, encryption. This is a security layer applied during preparation, especially for sensitive data. And the key point from the sources is that you need it in two places: data in transit and data at rest, although the sources call it data at storage.
Protecting it while it's moving and while it's sitting still.
Exactly. In transit means protecting it while it's crossing a network, maybe going from your website database to your analytics server. Encryption prevents eavesdropping. At rest, or at storage, means protecting the data while it's stored on a hard drive, in a database, on a backup tape. This protects against someone accessing the storage medium itself.
What risks does encryption guard against, and why both places?
It's your main defense against data breaches making sense to attackers. If someone intercepts data flying across the network, or steals a hard drive, or hacks into a server, if the data is encrypted, it's just scrambled nonsense to them without the decryption key.
Makes the stolen data useless.
Hopefully, yes. And you need it in both states because data is vulnerable in both states. Networks can be insecure. Storage systems can be compromised. Encrypting during transit and at rest covers the main vulnerabilities, creating layered security. For personal data or regulated data, it's usually mandatory.
Okay, so preparation,
Hmm.
validation, integration, cleaning, encryption, a huge critical step. After all that, data might go to step 4. Synthesis.
Right. Synthesis is positioned as the bridge between preparation and usage. It's often useful, but not always mandatory.
What's its job?
Its main job is to create new information from the prepared data, specifically to make analysis or reporting easier and faster down the line. You're calculating things or reshaping data based on how you know it will be used.
Pre-calculating metrics or creating summary views.
Exactly. Deriving new fields or aggregating existing ones. If your clean prepared data already has everything you need in the right format, you might skip it. But often, analysts need things that aren't directly in the raw data.
Like the net sales example.
Perfect example. Your raw data has gross sales, returns, discounts maybe. In synthesis, you create a new field, net sales, by calculating gross sales minus returns minus discounts.
So analysts don't have to recalculate it every time.
Right. It's pre-calculated, consistent, ready to use, saves time, reduces errors.
How else does synthesis make data more useful? Other examples.
Well, besides calculations, it could involve aggregation, like rolling up daily transaction data into weekly or monthly summaries, or creating derived categories, maybe grouping customers into high value, medium value, low value based on spending patterns, or calculating complex KPIs that combine several raw metrics.
So it moves from raw facts to more readily consumable information.
Precisely. It adds context, summarization, or key metrics that directly support the analysis or reporting tasks. Think about calculating average order value or customer lifetime value. These are often synthesized fields built from multiple raw data points.
Makes sense. Prepping the specific views needed. Okay, so definition, capture, preparation, maybe synthesis. Finally, the data is ready. Step 5, analytics and usage.
Yep, this is where the data gets put to work inside the company. It's where the value is realized.
What happens here?
This is where people build reports, create dashboards, run analyses to spot trends or problems. And critically, it's where insights from that data actually inform business decisions.
Visualizations, models, decision-making.
All of that. This stage lasts as long as that particular data set is actively useful for internal teams. Could be days, weeks, years.
And the sources were really clear about the scope here.
Very clear, and it's a key distinction. Step 5 is strictly about internal use, internal reports, internal analysis, internal decisions. It does not include sharing data outside the company walls.
Okay, internal use only, if they do need to share it externally.
That's a whole separate stage. Step 6, publication.
So publication means taking data prepared for internal use and sending it out.
That's the idea. When the business decides to share data or insights derived from it with external parties, customers, partners, regulators, the public.
Examples given were things like customer statements.
Yep. Sending a customer their monthly account statement is publishing data to them. Releasing official financial statements to the public or regulators is a major form of publication. Sending a price quote to a potential customer, also publication.
Okay, actively pushing data out. And the sources flagged a really big consequence here regarding control.
This is the crucial point they make. Once you publish data, once it leaves your systems and goes to an external party, you fundamentally lose sole control over it.
Lose control? How so?
The recipient now has a copy. They operate under their own rules, their own security practices, maybe different laws. You can't easily force them to delete it later. You can't fully control if they share it further or how securely they store it, unless you have very strong contractual terms. But even then, enforcement is tricky once it's out of your technical grasp.
Wow, that sounds risky. What does that loss of control mean in practice? Why be so careful about publishing?
It means you have to assume the worst, practically speaking. Assume that published data could be misused, leaked by the recipient, shared with competitors, kept forever, analyzed in ways you never intended. Because you've lost direct technical control, the sources strongly advise extreme caution. You must carefully consider the sensitivity of the data before publishing. What's the risk if this gets out? Are the contractual protections adequate? It's a major point of potential liability.
That definitely raises the stakes for step 6. Okay, so data is used internally, step 5, maybe published externally, step 6. What happens when it's just not needed for active work anymore?
That leads to step 7, archival. This happens when data is no longer frequently accessed for daily operations or analysis, but you still need to keep it for some reason.
Like for legal reasons or historical lookups?
Exactly. Compliance, audits, occasional historical analysis. The action here is moving it off the expensive, fast, active storage systems onto cheaper, slower, passive archival systems. Think long-term storage.
Why bother moving it? Why not just leave it?
Several good reasons listed. Cost is a big one. Active storage is pricey. Archive storage is much cheaper. Performance getting old. Unused data off active systems makes them run faster for the data people do need. And security, reducing the amount of data, especially older, potentially sensitive data, on your main actively targeted systems can lower your risk profile.
So save money, speed things up, reduce risk. Makes sense.
And a best practice mentioned is crucial. Test the archive data before you delete it from the active system. Make sure the transfer worked, the data is complete in the archive, and you can actually get it back if needed.
Right. Don't want to archive corrupted data and then delete the only good copy. Why is just keeping everything on active systems a bad idea?
It's hugely inefficient and risky. Performance degrades, backups take longer, queries slow down. Costs balloon, you're paying top dollar to store data nobody uses. And the risk piles up. Every piece of old data, especially sensitive stuff, is a liability waiting to happen in a breach. Plus, regulations like GDPR often mandate data minimization. You can't legally keep data forever if you don't need it. Archiving is responsible lifecycle management.
Okay, archival is for data that's dormant but needs to be kept. What's the absolute final curtain call?
Step 8, purging, the end of the line. This is where data is permanently irreversibly removed from all company storage. Active systems, archives, backups everywhere.
Gone for good.
That's the goal. But 2 critical checks before you hit the big red button. First, are you absolutely sure nobody in the business needs this data for any legitimate reason anymore? Has it truly reached the end of its useful life?
And second,
and crucially, are there any legal or regulatory requirements to keep it longer? Industry rules, financial record laws, litigation holds. You must confirm there's no obligation to retain it before purging. Get that wrong, and you're in serious trouble.
like keeping tax records for 7 years or whatever the rule is.
Exactly that kind of thing. Only once you've cleared both hurdles, no business need, no legal need, can you actually purge.
And the sources mentioned ensuring it's completely purged.
Yes, this needs to be thorough. Not just deleting a file, which often just removes the pointer. Depending on sensitivity, it might mean secure wiping techniques that overwrite the data, or even physical destruction of the drives or tapes, and verifying it's gone from backups too. It needs to be truly irrecoverable.
What are the risks? Failing to purge versus purging too soon.
Both are bad. Failing to purge data you don't need, especially sensitive data, increases your risk exposure in breaches, can violate privacy laws, and costs money for storage. Purging too soon, before legal or business needs are met, is potentially catastrophic. You could fail audits, lose lawsuits because evidence is gone, or be unable to do critical historical reporting. It requires strict adherence to documented retention policies and often legal review.
Wow. Okay, that wraps up the 8 steps. Definition to purging. It's a much more involved process than I think most people realize. A very clear framework.
It really is. Structure for the data's journey. And now that we have that life cycle mapped out, let's loop back to step 2, capture creation, and look more closely at the different ways data actually gets into that cycle in the first place.
Right, because the life cycle starts once the data exists. How does it start existing?
Yeah.
The sources laid out 3 main collection methods.
Yep. They described ETL extract, transform, load, then active data collection, and finally, passive data collection.
Let's take ETL first. It's used when data already exists, right?
That's its main use case. ETL is about moving and preparing data that's already sitting in some system, internal or external, and getting it into a target system, usually a data warehouse or is similar specifically for analysis.
And the name tells the story. Extract, transform, load.
Exactly. First, extract. You pull the data out of its original source, could be a database, an ERP system, files, whatever.
Got the raw stuff.
Then, transform. This is the makeover stage. You clean the extracted data, fix errors, standardize formats, maybe aggregate it, filter it, calculate new fields, basically get it ready for analysis.
Hey, that sounds a lot like the preparation and synthesis steps we just talked about in the life cycle.
Overlaps significantly, yes. The transform part of ETL often is where much of the preparation and synthesis happens, but it's done as part of the process of moving the data specifically for an analytical purpose. It bundles those data quality steps into the pipeline.
Okay, and then the last step, load.
Load is just putting the now transformed data into its final destination, the data warehouse, the reporting database, etc. Ready for step 5, usage.
And the source is called ETL, a more specific method for collecting existing data for analysis. What's that mean?
It means ETL is usually purpose-built. You design an ETL process to grab specific data points from specific sources, transform them in a specific way to answer specific business questions, or populate a specific dashboard. It's targeted data gathering and preparation, driven by the analytical need, rather than just, say, logging every transaction that happens.
Got it. ETL for existing data targeted for analysis. What's the second method?
Active data collection. This is different because it's about gathering new data and doing it directly from people.
Asking users for info.
Exactly. The key is the direct ask. The user knows they're providing data in response to a request.
Examples given were surveys, interviews.
Yep. Filling out a survey, answering questions in an interview, that's active collection. Also, filling out forms name, email address on a sign-up page or checkout. The user is actively typing or selecting their information.
When would you use this? What are the pros and cons?
You use it when the data you need simply doesn't exist anywhere else, like opinions, preferences, direct feedback.
Can't get that from a database.
Right. The pro is you can ask precisely what you need to know. You usually get explicit consent. Cons are, well, people might not respond. It takes effort to create and run surveys or forms, and the answers might not always be accurate or truthful depending on the questions and context.
Okay. Active is direct asking. What's the third one? Passive data collection.
Passive collection is gathering data without a direct, explicit ask at that moment. It's more about observing behavior or system interactions automatically.
Without asking. How does that work?
Well, the sources link it to technology like IoT and AI, making things more connected. It happens often as a side effect of using a system.
Examples were cookies tracking web usage.
That's the classic example. You browse a site, cookies track your clicks, pages viewed, time spent. You might agree to cookies generally, but you're not actively reporting each click. Another example is systems logging timestamps, when you logged in, when you added to cart, when you checked out. It's recorded automatically based on your actions.
How is that fundamentally different from active? And what issues come up?
The core difference is observation versus asking. Passive is often invisible to the user, captures real-time behavior potentially very granularly, but that invisibility is also the challenge. It raises huge privacy and ethical questions. Are users truly aware of what's being collected?
Even if it's in the privacy policy no one reads.
Exactly. So it demands real transparency from companies, strong security, and strict compliance with privacy laws like GDPR or CCPA, which have rules about collecting personal data this way. And the sheer volume of passively collected data can be a technical challenge too. Storage, processing, making sense of it all.
Right. Easier collection means greater responsibility.
Absolutely. So those three, ETL for existing data, active for asking, passive for observing, are the main ways data gets captured or created, kicking off its journey through the life cycle.
And putting those collection methods together with the 8 steps of the life cycle, that gives the whole picture, doesn't it?
It really does. From origin to end of life, it shows data isn't static, it's dynamic. with rules and needs at every stage. Understanding that whole flow is key to using data well and avoiding the pitfalls.
Okay, this has been incredibly insightful. We've really unpacked the importance of data, traced its entire life cycle, definition, capture, preparation, synthesis, usage, publication, archival, and purging. And we looked at how it gets collected via ETL, active and passive methods.
And hopefully, understanding this structure from your sources gives you, the listener, a really solid framework for thinking about data management, why each step matters, and how it all connects to creating reliable insights.
We definitely encourage you to use this lens. Think about the data you see every day. Where might it have come from? What journey might it have taken? Where does it live? And what happens when it's no longer needed?
And maybe one final thought to leave you with, based on everything we've discussed. Given the complexity and the sheer effort involved in managing data properly through its entire life cycle, the careful planning and definition, the meticulous work and preparation, the critical decisions around publication, the finality of purging, and considering the immense volume and variety of data being gathered constantly through all these methods, what does all that complexity and responsibility tell us about the level of trust we can, or maybe should, place in the data that influences so many of our decisions and shapes our view of the world?
That's a really potent question, something to definitely chew on.
Eh.
Thank you for joining us for this deep dive. Keep questioning, keep exploring.